So in this video we want to review what we have learned about properties of real numbers under the operations of addition and multiplication. And we want to do this because we want to establish the same type of properties for matrix addition and matrix multiplication. So this video is just to remind us about what we've already learned, having gone through K-12 and having done mathematics. So one of the things that we should know by this time is that addition and multiplication are both associative for the real numbers. So remember, the double barred R represents the real numbers, or the numbers on the real number line. So by associative we mean that the order in which we add doesn't matter, or the order in which we group when we add doesn't matter. So if we do A plus B first and then add C, we'll get the same thing as if we do B plus C first and then add the A. So we can group things in whatever order we want using the associative property, and both addition and multiplication are associative. So we can multiply A times B and then multiply by C, or we can multiply B times C first and then by A. And Karina, if you're a math ed major, this is going to be the sort of thing that you'll be expected to remember when you take the NES test at the end of your bachelor's degree. So they'll test to make sure that you remember these words. These words will be important to remember, to have memorized, and to understand. So addition and multiplication are both also commutative, and that means that the order in which we do it doesn't matter. So if we add A plus B, we'll get the same thing as if we add B plus A, and A times B will be the same thing as B times A. So the commutative property, we can change the order of the multiplication, whereas the associative property tells us that it's okay to group the items in any order we want. We don't change the ordering of the items, but the grouping. Commutative property lets us change the order. We also know that an additive identity exists, and the additive identity is 0. So it's called the additive identity. It preserves the identity of any real number we add 0 to. So if we have a real number A and we add 0 to it in either order, the identity of A is preserved. A will still be A under addition if we add 0 to it. And then we have a multiplicative identity, which is 1. And 1 is the number that preserves the identity of any real number A under multiplication. So A times 1 or 1 times A will still be A. 3 times 1 is 3. Multiplication by 1 preserves the identity of the number 3. Multiplication by 1 preserves the identity of any real number under multiplication. And then every real number A has an additive inverse, which is the opposite of A. And all the additive inverse is the number we add to a number to get the additive identity, which is 0. So if I have negative 3, the additive inverse of it, so negative 3 plus, the additive inverse of 3 should be the opposite, the additive inverse of negative 3 should be the opposite of negative 3, but the opposite of negative 3 is just positive 3. So 3 and negative 3 are additive inverses of each other, because when we add them together we get the additive identity, which is 0. And we also know that real numbers satisfy distributive law. So if we have real numbers A, B, and C, and we have A times parentheses B plus C, we know that we distribute the A into the parentheses, and we can put the A at either side of the parentheses and distribute in from either direction, B times A plus C times A. And distributive property really tells us how multiplication and addition play together. And what we want to do in the next video then is walk through and identify that these same types of properties, with the exception of the commutative property for multiplication, these same properties hold for matrix addition, how we defined it, and matrix multiplication with how we defined multiplication.